All right, hello, freshman science students. This is Mr. Delane, and I am going to go over your notes here. This is an example of a pulley problem, and using it to calculate efficiency of a machine. So we're going to be talking about AMA, IMA, and efficiency. So when you have a pulley system like this, um, you can measure distances and you can measure forces. Okay. The distances that you can measure would be the distance that this load right here is pulled up. The distance you could measure would be the distance that you pull on the rope. So as someone was pulling the rope toward themselves, the load would go up like this. And the interesting thing that you find when you do this type of a thing is that you, on this pulley system specifically, where you have four pulleys, you would measure that you pulled the rope 4 meters, and the load only went up 1 meter. Okay, so there's a big difference, and it's because of the number of pulleys that you have here. The amount of force that you have here is also interesting because if this load weighed 200 kilograms, that would be 1,962 newtons of force. It would only take 501 newtons of force for you to pull that load of 1,962 newtons. Okay, so it would take a lot less force for you to pull because this pulley system here is multiplying the amount of force. Without this pulley system here, it would take you 1,962 newtons to pull up this load here because that's how much the load weighs. Okay, so the pulley system is giving you a mechanical advantage. A mechanical advantage is how much a simple machine multiplies your effort force by. So we talk about two different types of mechanical advantage. One is actual mechanical advantage, or AMA. The first A stands for actual. Okay, when we're talking about actual mechanical advantage, we're comparing the forces that are being compared. In other words, how much force do you pull with, in this case 501 newtons, compared to the force of the load, in this case 1,962 newtons. So you would compare the load force divided by your input force, okay, how much muscle. And you just divide those. That line right there means divide, and you get an AMA of 3.916. We can also compare distances, which is what we call ideal mechanical advantage. Again, I in the IMA stands for ideal. So ideal mechanical advantage ignores friction. And it's a very easy thing to calculate. Actually, we don't even have to calculate it. All we have to do is just count the number of supporting ropes in a pulley. Now, this is unique to a pulley system, but it is true. You can just count the number of supporting ropes. So here's your pulley system, and you have 1, 2, 3, and 4 ropes that support this load. The fifth rope is not supporting the load, but it's the one that you're pulling on. So you ignore the rope that you're pulling on, but this has an ideal mechanical advantage of 4. Is this pulley system perfect? No. Ideal mechanical advantage ignores friction, but actual mechanical advantage takes in consideration friction. There is no such thing as a perfect machine. And actual mechanical advantage, takes in consider friction, so it will always be less than the ideal mechanical advantage, which ignores friction. If we were going to calculate the efficiency of this machine, efficiency equals AMA divided by IMA. So in this case, we calculated the AMA was 3.916. The IMA was 4. You divide those two and you get 0.979. We multiplied that number right here, 0.979, times 100 in order to change it to to change it from a decimal number into a percent, and we calculate then that the percent efficiency of this pulley system is 97.9%, which is a good efficiency. Hope that helps you out to understand these notes. Please ask if you have any questions, and good luck on this.